So here we have question 6, which is about volume, with a little bit of differentiating going on at the end of the question B. So let's get started. So we have our total surface area of this shape here that we get given this prism. So show that xy plus x squared equals 12. So that looks like a load of nonsense actually at the beginning. It's just kind of no context, no background. We're just going to kind of tell you, show that this equals this. So let's try and work something out here. We've got all the x's and the y's given to us as dimensions of this, and we get told that the total surface area is 144. So let's try and make something equal to 144. So let's try and go through these surfaces. Let's go through the bottom surface here. So this bottom surface. So that is going to be 4x there times by y there. So we're assuming that y carries on down here. So like this here, that's going to be y there. So we've got 4x y for that bottom one there, and then I'm going to move it onto this kind of like this top angled surface across here, this purple one, and I'm going to say that is y times by 5x. That's just a rectangle there, so plus 5x y, and then we're going to go for this back surface, the back of the prism there. That one is going to be 3x times by y, so plus 3x y, and then what we have is the two kind of triangle pieces here. Let me see if I can, that's not very accurate, but you can see, so this one here, and then the same on the back there, this triangle piece. So you understand what I'm talking about. So these two here, so they are going to be so let's do another plus here, so they're going to be half times by 3x times by 4x. So 3x times by 4x, and of course we have two of them. So we have two of them. Alright, let's see if we can find some sense in here then. So this 4 and this 5 and this 3, they're going to add up. So we're going to get 144 is going to be equal to 5 plus 4 is going to be 9, plus 3 is going to be 12. So we're going to get 12xy, then plus, well, this half is going to cancel out with this 2, and then we're going to get 3x times by 4x. So we're going to get 12x squared, and then hopefully you've seen it, we can divide everything by 12. Divide everything by 12 so that we get 12 is equal to xy plus x squared, which is what we were aiming for right at the beginning. So it wasn't very clear what we were being asked to do really, but we've got there nonetheless. So let's draw a line under that and move on to the second part. So show that the volume is given by this. Well, we can calculate the volume. We know how to take the volume. We go this end triangle piece, the area of that, times by this length here, which is y. So the area of that triangle piece there, that is going to be 3x times by 4x. Let me get that right. 3x times by 4x times by a half times by a half. So that is going to be our triangle piece there. So that is going to be equal to, it's going to be 12x squared over 2, so it's going to be 6x squared. 6x squared is going to be that. Then times by y, so new colour here. So 6x squared y, that is going to be our volume for for this prism. So we need to get it into this form with only x's in it. With only x's. Well, what we can do there is split this up. We can say that 6xy is equal to, if we try and get an xy in there, we can say it is xy times by 6x. That's the same thing, right? I'm just taking out xy out of that. And then from this up here, we can say, let's go for purple. So we can say that xy is equal to 12 minus x squared, because I've just taken away x squared from both sides there to get that. So let's put that into there. And then what we'll get if we do that is we will get, let's do that. So we'll go 12 minus x squared, 12 minus x squared times by 6x. And hey, what do you know? 6 times by 12 is going to be 72, carry the x, and then minus 6x cubed. That is our volume, that equals V. And that is what we were aiming for. So that's what we've got there in just x terms. So let's move on to our differentiating part of the question. Let's do this down here, B, part 1, part I. So find dv over dx. So sometimes you've got a v here, sometimes it's dy over dx. So if you have y equals whatever you have, so you do exactly the same thing as what you would normally. So we're going to say that dv over dx is going to be equal to 72 minus 18x squared. So you've taken that x out of there, and then 3 times by 6 is 18, and then take that down and make that a 2 there. So that is what we've done there. That's for 1 mark. That's easy enough, hopefully. So let's move on. I'm going to make myself a bit of space now. Let's come down here. So show that v has a stationary value. A stationary value, that is the important part of this. A stationary value means that the gradient is equal, so stationary value means that the gradient is equal to 0. So in this case, normally it's dy over dx is equal to 0. So in this case, we're going for dv over dx has to be equal to 0. So we're going to try and make this 18 or minus 18 x squared plus 72. We're going to try and make that equal to 0. Well, how do we do that? Let's go over here to do that. So we can say that 18x squared is going to be equal to 72. All I've done there is add 18x to both sides, so that we've got 18x is equal to 72. And now, here we go, x is equal to 2, so x is equal to 2. So let's put a 2 in there. So 18 times by 2 squared is going to be equal to 72. So 18 times 4, guess what? It is equal to 72. So we've shown that it's a stationary value by putting 0 in there and saying the gradient is 0, and then we put 2 in there to say that when this graph, this thing is at 2, then we've got a gradient of 0. So the last part of the question, part C. So find the second derivative and then determine whether it's a maximum or a minimum. So let's do the first part. First part first. Let's do this. Let's find the second derivative. So I'm going to go down a bit further here. Hopefully you'll stay with me for that. So part C, the second derivative. Well, we found the first derivative. That's up here. So then let's do exactly the same again. Well, this 72, that's going to disappear because there's no x there. That's just a constant. So d squared v over dx squared is going to be equal to, so there's no 72 there, then minus 18 times by 2 is going to be minus 36x, and then this 2 is going to become a 1. You could write the 1 in there. I'm not going to because you don't need to. So let's go back to green. So hence determine whether v has a maximum or minimum when x is equal to 2. So let's put 2 in there. So if we put 2 in there, then we are going to get 30 or minus 36 times by 2. That's going to be equal to minus 72. Now, may sound obvious, minus 72 is less than 0. This is how we determine whether it's a maximum or a minimum, and it's kind of counterintuitive here. What you've got to remember, if this number is less than 0, then it is a maximum value. You'd expect it to be the other way around. You'd expect the low number to be the minimum and the high number to be the maximum. But for whatever reason, when you have a graph like this and you have, so you have 2 points like this, then you're going to get, this is going to be one point where the gradient is 0, and this is going to be another. And on this one, this is the maximum, and then this little one, this is the minimum. So this is the minimum, this is the maximum. So we've just found out by doing this, the second derivative and whatever, that this maximum point here is when x is equal to 2. I mean, this graph doesn't look like that, but you get the idea. So it's a maximum value because the second derivative is less than 0. That is the question. I will see you in the next video.